Quantitative analysis, numerical concepts, probability of independent events. The probability of independent events. This occurs when you wish to calculate the probability of two independent events, where the first event, probability of A, does not affect the probability of the second event, the probability of B. Let's have a look at the multiplication rule, or the AND condition. If you toss a coin twice, what is the probability that in both instances the coin lands on tails? So what we're after here is what is the probability of landing on tails with the first toss, and what is the probability of landing on tails in the second toss. So firstly, what is the probability on the first toss the coin lands on tails? Again, we know that a coin has two sides. Therefore, the denominator will equal 2. And what is the probability that the coin lands on tails? Well, there is only one tails on a coin. Therefore, the probability of landing on tails for the first throw is 1/2. Let's look at the second event independently. What is the probability that on the second toss the coin lands on tails? Again, we know that there are two sides to a coin, so this becomes our denominator, and that there is only one tails on a coin, and this becomes our numerator. Therefore, the probability of landing on tails in our second throw is 1/2. Now we need to look at what is the probability of landing on tails on the first throw and the second throw. So what is the probability of A and B occurring? To arrive at your solution, we need to multiply the first probability by the second probability. So 1/2 multiplied by 1/2. And this equals 1/4, because we multiply the two numerators together and then we multiply the two denominators together. So 1 multiplied by 1 equals 1, and 2 multiplied by 2 equals 4. To express this as a decimal, 1/4 equals 0.25. And if we multiply this decimal by 100, then the answer is 25%. So for the probability that in both instances the coin lands on tails equals 25%. Let's have a look at workbook exercise 3A, question 8. A coin is tossed and then a die is rolled. What is the probability of obtaining a head and an even number? Let's first look at what is the probability of tossing a coin and landing on heads. Firstly, we know that there are two sides to a coin, therefore that becomes our denominator. And we know that there is only one head to a coin, so that becomes all possible outcomes, which is 1. Therefore, the probability of tossing a coin and landing on heads is 1/2. So I'm going to call this the probability of A. Now we'll have a look at the probability of B. If I throw a die, what is the probability that I'm going to land on an even number? Firstly, what are all possible outcomes? I know that a die has 6 sides, so this becomes my denominator. How many even numbers are there on a die? Well, there is the number 2, the number 4, and number 6. So there are 3 even numbers on a die, and that is the possibility of an event occurring, which is 3. Therefore, to throw a die and land on an even number will be 3/6. Now we need to know, well, what is the possibility of obtaining a head and an even number? So this becomes the probability of A and B. And to solve this answer, we need to multiply the two fractions together. So 1/2 multiplied by 3/6. Which equals 1 multiplied by 3 is 3, and 6 multiplied by 2 is 12. Now this fraction can be simplified because both the numerator and the denominator can be divided by 3. Therefore, if I divide these numbers by 3, my answer is 3 divided by 3 is 1, and 12 divided by 3 is 4. What is the probability of obtaining a head and an even number? It is 1/4. Expressed as a decimal equals 0.25, and expressed as a percentage equals 25%. Now let's have a look at the addition rule, the OR condition. A 6-sided fair die is rolled. What is the probability of rolling a 2 or a 5? So again, we need to look at each event separately, and then we need to calculate the two events together. So the first one is, what is the probability of rolling a 2? Well, again, we know that a die has 6 sides and that there is only one 2 on a die. So the probability of rolling a 2 would be 1 over 6. For the second event, what is the probability of rolling a 5? We know again that the die has 6 sides and there is only one 5 on a die. So the probability of rolling a 5 is 1 over 6. We now need to look at what is the probability of rolling one or the other. We've looked at the events independently. Now we need to add them together. Therefore, the probability of A plus the probability of B equals 2 over 6, because we add 1 plus 1 equals 2, and we carry forward the denominator being 6. We can simplify the fraction 2 over 6 because both the numerator and the denominator can be evenly divided by 2, and this will give us an answer of 1 over 3. So what is the probability of rolling a 2 or a 5? It is 1 over 3, or expressed as a decimal, 0.333, converted into a percentage equals 33%. Let's work through workbook exercise 3A, question G. A single card is chosen at random from a standard deck of 52 playing cards. What is the probability of choosing a king or a club? So what we need to find out here is, what is the probability of event A or event B occurring? Let's have a look at the probability of event A firstly. What is the probability of choosing a king? I know that there are 52 cards in a playing deck. I also know that there are 4 kings. So my probability of A occurring is 4 over 52. Let's have a look at the probability of B. What is the probability of selecting a club? Again, I know that there are 52 cards in a standard playing deck, and I also know that there are 4 suits, and each suit holds 13 cards. Therefore, the probability of B occurring is 13 over 52. Now, because each of these probability holds a similar card, which happens to be the King of Clubs, we need to include one final step to this equation, in that we need to take one King of Clubs away from our solution. Therefore, our probability calculation will be the probability of A plus the probability of B minus the probability of A minus B. Therefore, the probability of A was 4 over 52. And we add this with the probability of B, which is 13 over 52. And to add these together equals 17 over 52. We take away the probability of A minus B, which happens to be 1 over 52, because there is one King of Clubs in a deck of cards. Our answer, therefore, is 16 over 52. Therefore, what is the probability of choosing a king or a club in a deck of 52 playing cards? It is 16 over 52. Or, simplified, both numbers can evenly be divided by 4. 16 divided by 4 equals 4. And 52 divided by 4 equals 13. To express this as a decimal, the answer is 0.307, and as a percentage, it will equal 30.7%.